So we were able to start our thread. And if you try to start more than one, it will end up with illegal state exception. So are we clear till here? Like, you have any questions?
No, sir.
Okay. So now let's see, there's a run method, right? What if I call the run method explicitly by my own way? Let's see that too. So like, instead of calling start, what if I call the run method directly? What happens? Let's figure it out then. Let's comment this start and let me call t1 dot run. Okay. And then we run it. So if you see this time, it's running parent, running thread, and running main. Okay. The same output what you got when you call the start method. So what happened here is it compiles, but no separate call stack has been created. So if you have thread, it will have its own memory. It will have its own thread process, own data, own code, and own registers, right? The similar one which you have as your process. But if you call it run, what happens? It's just a thread object, which is an overridden method, because even your thread class has that particular one, right? Your thread class also has your run method. So even this is an overridden method from your thread class. So whenever you create an instance, right, using a thread object, what happens? It will just call that as a separate method and not as a thread method. So it will be like a separate one. So there is no separate call stack happening here. So that is the reason we invoke a start method and not run method. So the basic concept why we go for thread is it will start in separate call stack. So what is a call stack? The call stack is something like in your program when you execute, the first one would be your main program. The order of execution was first main. You saw that execution order. So the first will be your main method. On top of that, you'll have your second one, which is the thread start method. So the start method will internally call the run method. So you should have a separate call stack. But when you call it directly run method, what happens? It will be added in the same way. So this is the difference. If you have it using a start, what happens? That would be a separate call stack, and you will have your separate start method over here. So this will be separate thread, and whatever you want to handle in this thread, it will be handled in this particular one. There is no interaction here. But when you just call run method, it will be considering a separate normal separate method, and it will call it on top of your main. So this will be in a single stack, whereas here it will be in a separate stack. So that is the reason we call start method and we don't call run method. So here we don't have a separate call stack. And here we maintain a separate call stack. So you got the idea about why do we need to go with start and not with run?
Separate call stack means, like, for example, you mean to say, like, when we use start, what it does, like, on top of main, like, it got created, something like that.
Yeah, same thing. So if you just call run method, what happens? The run is nothing but overridden method from your parent class thread, right?
Yeah.
So it's a normal method for the thread runnable. It is not treated as a thread instance itself. So it will be like in the thread runnable, I have the main method, and we have this main method, and within that you're using a run method of the same class. That's it. There's no difference. So in that case, what happens here? Your run method will be in the same package, the same class. But if you give it as a start, what happens is a separate thread which you have created explicitly, and you're kickstarting this thread, and this thread internally calls the run method. Then there would be a separate thread created like this, and this would be the one called T1. This is a thread instance, and this would be your main instance. So you'll have two separate stacks, and whatever you need to handle as part of T1 would be handling in a separate one, and whatever you need to handle as part of main will be here. There won't be any relationship, and there won't be any memory management also between these two. It will be completely different. Okay. So why do we need to do that? What happens if we use a separate stack is something we learn in the multi-threaded environment. But right now, this would be the way for us to create our own threads. Okay. So the two ways to create is by extending and by implementing runnable interface. And every time you create your runnable interface, you have to pass your runnable, like whatever instance which extends or implements the runnable part, that has to be passed in your thread object, and you have to kickstart it. Okay, and you can't kickstart twice, you can kickstart only once. Okay, you can't call the run method, you can only call start method. Okay, so hope this is clear till now.
But if you call run method also, it is working, right? Like our
Working. In that
overrided
case,
thread
then you
is
don't need to go for thread, right? It will be a normal class, right? Why do you
normal
need
method calling.
to use a runnable interface? You can just have some parent class with some run method, and you can call that run method directly, right? You don't
Directly.
need the
Okay.
thread itself, right?
Okay.
So it will be a normal Java program execution if you use an interface concept. It will be a normal interface. But when you only use a thread, the purpose of thread and that deleted information would be started. So to make you more clear, what I can do is,
Like we don't specifically call that run, and that method override method will implicitly like will run with the object created for the thread. Right?
yeah. So let's say let me print the thread state this time and run it. So you see the runnable thread. This time, let me comment out this and just give me the t1.run. You see new method. So what happened? Your thread is not used. It is a normal method, normal run method logic you called, and that is the reason your thread was not created itself. Only when you call the start, it is actually migrating to a separate stack and treated as a separate thread. Okay. If you just do this, is a normal Java interface concept, right? You're just implementing and you're using the overridden method, you're reusing that method. It's a normal thing. So that is the reason your state is still new, because you just created your thread. You didn't use it. But only when are you using it? When you call the start method, only then that run is getting the run method is actually getting its purpose, and it is actually calling it in a separate flow where the run is also getting printed. If you see that.
Okay.
Okay. So that is the reason you need to have the start method alone. Otherwise, it would be like a normal Java program. There won't be any thread, multiple threads. You'll have a single main thread. That's it. Okay. So these are the ways to create a thread. So let's see what is a thread group and the priority, the basic things. Okay. So let's print it and see what the thread group is getting printed like. So right now the thread group is null. Okay. So let's print the state as priority as well. Let me run that. So you see the priority as 5. So let's go into that priority and understand what this priority is. So this priority is like, have you ever heard about preemptive scheduling? Like something in your OS concepts, something like preemptive, non-preemptive schedulers. Okay. So this preemptive scheduling is nothing but you have multiple threads, okay? Like thread 1, thread 2, thread 3, thread 4, thread 5. You never knew which thread should come first and which thread should go next. You never knew the order. What happens is internally the CPU will execute your processes either by using a time frame or by using like giving a higher priority. There are multiple ways. Okay, this higher priority and whoever has higher priority will be going first. So that concept is called as preemptive scheduling. And the time frame is like each thread should work only for 10 seconds. And if the 10 seconds is completed, it has to switch to the another thread. So you're actually slicing your frame. Okay, this is called as time slicing. Okay, there would be something called non-preemptive schedulers. So what happens in this case is they won't be executing on any priority. It would be a random execution. You never knew in which order your thread is getting executed. So this would be like completely a different, because we can execute only one thread at a time. So how many threads can get executed parallelly? You can execute only one thread at a time, right? So you should either go with this particular concept of priority, like whoever has higher priority, I'll give them first preference, and then rest of the other threads can work on. No, I want every thread to be in common. Like I want every thread to work parallelly. So I'll just give a time frame from each thread. So you work for 15 seconds, 15 seconds, 15 seconds. And then if this round is completed, I'll again complete with the second level of rotation. So this way of thing is called as time slicing. You're giving the time for each thread to work on. And if they can complete the task within that, then they are good to close the thread. If not, we have still need to wait for another 60 seconds to come back to the thread 1. Till then, it has to be in a waiting state. Okay. But if your thread completes its task, it can end up and it can clear its termination. It can end up with that. But if your thread work is not completed, then it is still in waiting state. So if it is in waiting state, what is the meaning? It's still in the CPU process is giving its energy to CPU to wait to complete its task. So if you see the task manager, so right now what happened here is I have like 34 tabs opened in my Google Chrome. So all are running parallelly. Okay. And if you see the CPU purpose, many of the things are in 0. But if you see the other things, the percentage is getting varied. What happens every time in the back end, this is actually going on in a rotation, time slicing manner. So this has been given priority. Next, later this has got 0.4 and later this got the overall percentage was 6.5. But internally, if you see these are static. So now now here you see 0.1. Next time this got a value. Next time this got. So this is happening in a rotation manner. Like whoever comes first, they will get the relevant percentage or relevant time slice. Within that, if you use that particular tab, that will work. Otherwise, you have to wait till that comes into picture. So you can see the observation, right? The difference. How is it happening in the backend?
Oh, yes, Megha.
So the same way, whenever you create your own threads in Java, you're prioritizing its thread value, like whether I can go with the default value or something minimal or with the highest priority. And so because you are creating your own threads to make your own thread to work on. So in that case, you need to give a priority to your threads as well. So that is the reason it is like defaulted with a value of, 5. So let's say thread priority. Yeah. So if you see here, the whatever priority you give, it is actually checking the maximum priority with 10, minimum priority with 5, normal priority with 5, and minimal priority with 1. Okay. So these are the default values for your thread to have either 1, 5, or 10. So whenever you create your own thread, it will be defaulted with a normal priority of 5. If you think that your thread doesn't require normal, it is like minimum value is fine because that thread is going to work very less. Then in this case, you can actually set with your own minimum priority value. But these are the things which we need to consider when we create your own thread. So let's say now right now I don't want priority with 5. So what I'm going to do is T1 dot set priority with thread dot minimum priority value. Okay. Now let me run it again and see what is the priority I'm getting. So this time I should get the priority of 1. But what happened? This is not set. The priority value is still with 5. So let me set a max priority. Even this time also I see the 1. So why this value is not getting set? The thing is, every time you set a value, it confirms like whether the new priority value is greater than max priority or less than minimum priority. So whatever I gave was 10. 10 is like greater than 10 fails, and the value is 10 is less than minimum priority. That is also fails. So it will not consider it. And now it also considers a thread group. In your case, the thread group was null. So how can I initiate a thread group? So what we can do is, first, let's create our own thread group. So till now, you have any questions, Janaki?
No, Sneha. Like we are trying to set that priority, but that if condition is not satisfied, so it is not getting set, right?
Okay.
Even the
so basically, yeah, exactly the same thing. So what is thread group is you're grouping your threads. Say when I said like giving the time frame for each thread, you can also group them. Say example, this is thread A, thread B, thread C. The top three are thread A, B, C, which have to be in a similar group. So they are all coming from a similar group and they have to be executed parallelly, or they have to have a similar priority. Whereas these two threads can work little later. The priority is not immediate thing. So in that case, what happens? We can have our own thread groups defined for it. So how can we create our own thread groups, and how can we use it in our Java classes? That we'll see here. Let me create a thread group instance. So you see a thread group class, and let me say like thread group equal to new thread group. Okay. And this thread group, let me, if you see this one, this is an overloaded constructor. If there is nothing, it will be defined with system. Okay. This also has a set group with string. So let me give a string called A group. Okay. I'm just giving the A group. Now, what I'm going to do is whenever I'm creating a thread here, right? Whenever I'm passing that, I'll be setting that whether that falls into that relevant group or not. So let's create one more thread. Thread T2 equal to new thread. So you see here a thread which is having a thread group runnable string, thread group runnable, and thread group string, right? So what we're going to do is we are going to pass the thread group and then runnable and some string for our understanding. So this is the way we are going to use it. So let me give the thread group as TG, and I'm going to pass the same run instance which has been created above, and let me create it as 1. Okay. And now let me create one more thing. Let me create two more things. So it will be easy to understand what thread groups looks like. So this will be saying, let's just change this to okay. So let me create a new new instance. Anyway, I have run, right? So was that printed now? So this time let me print the thread 2's thread group. So you see here a name with A and the maximum priority of 10 has been given. So now the priority value, whichever you set as part of a thread, has been considered. Okay, but you're still the T1 priority is same. Now let me say T2 dot set priority with 1. And let me print here. T2 dot get priority. Let me run this. You see, the value has been set with 1 and my thread group is with name A. So if you want to group every thread to a similar, all the threads into similar group, you can have it its own name and you can categorize it based on your usage. Instead of just executing a thread, you can execute that thread group and you can set your own priority. Okay. So are we clear till now in the priority part and thread group, or you have any questions?
Yeah, clear.
Okay. So yeah, so we just learned very basic thing like how to create thread, what are the properties of your thread, what is the priority, why we need a priority on the thread part. Like it's basically to execute your list of threads, and how to group your threads. For that you have something called thread group, and how exactly in the backend the thread starts and executes. Where your major logic has to be, it has to be on your run method, but the kickstart should always happen from your start method. These are the things, and what are the two ways to create? By either extending your thread class or by implementing your runnable interface. These are the ways to create a thread. So we'll explore how we can use these threads to improvise our own logic in the rather than having our own main method and executing it. What is the benefits of using our own thread and executing from run method? We'll see that in our next class.
Okay. Can you come a little bit down once, like the second thread, like okay. Here in the set priority, we can directly give the value, right? Like no
Yeah,
need to
actually
give
this
the,
is not working. That is the reason. Let me give 10 here. It should work. I'm not sure why this isn't working because your T1 is not working. Let me check on this. But usually what we do is we either use the constant of the value max or min priority, or we hard code the values.
okay.
I'll check it out why this is not happening, and then I'll tell you to go tomorrow.
Okay.
Yeah. So yeah. Did you try in the yesterday's program with map in using your object-oriented output stream and input stream?
No, Sneha, like I couldn't watch the video also. I think it is yet to be uploaded.
Yeah, I'm yet to upload. You didn't attend yesterday's class?
I have attended, like I'm not clear in that buffer because I missed that, right? So I'm trying to follow up from the first class, like from the read string and input stream and all those things actually.
Okay, fine. Okay, sure.
Yeah.
Yeah, I'll just upload and please follow up because we'll be doing all those activities together, the collections and everything in the thread also. So
Yeah,
make sure that you are in sync, otherwise it will be trouble.
Okay.
Okay. Yeah. Thank you. Have a good day.
Thank you.